Okay, so we have a color space. We have chosen the range of colors we want to represent. Let me draw it here. We have this. This is the color space, and we have the image divided in squares, in pixels, and we need to uh, put an information here. This will correspond to a point into the color space we have chosen for the image. And this is the color space, but the way that we map the points of the color space to numbers is what it's called the color model. Okay, the color model will transform a wavelength into a number and a number into a wavelength. This is a color model. One color model that you will probably know is the RGB model. We have here a page. With the RGB model, what we are doing is pick a color and divide it in three components: red, green, and blue, because you can create whatever color mixing lights of mixing red light, green light, and blue light. So here to map, remember we have the color space, we have a point here. To map this to the RGB color model, we divide this wavelength in its three components. So here, for example, you have an example. This is RGB, and if we the values in RGB usually ranges from 0 to 255. This is 1 byte. 0 means no red light. 255 means the maximum of red light we can have. So here, the red color will be 255, 0, and 0. We have the hexadecimal representation. Let me increase the resolution. So a red, if we use only red light, no green light, no blue light, we have, of course, a red color. And this is represented as red, the green, and the blue. And with this we can transform a color, red, into a number. Okay, this is a color model. If we, for example, put a 000, this will be black, because if we have no light, everything will be dark. In green will be green, and we can mix them. If we mix red and green, we will have yellow. Okay, if we mix blue and green, we will have cyan. Okay, this is the RGB. The problem with with RGB is that it's very difficult to find related colors. So, for example, if we want, uh, let me modify here. Okay, imagine that I need a darker color. So I will move this to the bottom. Right? In this case, it's very easy. I'm going to pick a more complex example. For example, this one here, this color. Okay, imagine we have this range of color. I'm going to put 95 here. This range of colors, and I have this color here. This is the red component, the green component, and the blue component. And I want to make it darker. So I have these values and 72. I'm going to make it darker, just moving the point to the bottom. And I've modified the value of the three components. From here, I can see easily here that this color is related to this color. And if I hadn't this square, it will be very difficult to make a color darker. If you want to try it, just using RGB, try to make a color darker, maintaining the tone, and you will see that it's very, very difficult. So there is another color model that's hue, saturation, and light. Okay, I'm going to show you it. The SL model. This is a different model. HSL, I think is hue, saturation, and luminance. I think I'm not sure. And the components of this color model. Remember that we will always end with a number. Here we can these three numbers. In this case, this is the RGB model. This is the RGB model. This is the HSL HSL model. You pick the tone. This is the hue. For example, I want blue colors, or I want pink colors. This is the first component. Then I pick the saturation. The saturation is zero. Saturation is gray. 100% is the uh, more saturated, the more quantity of that color. Okay, so and then I pick the luminance. This is the saturation, and this is the luminance. Zero luminance is completely dark. 100 luminance is completely white, and between them we can uh, there is a range of colors. But with this model, it's easier to find related colors because, for example, if I pick this green color, I can darken it just moving this one. Look, that two components don't change. We are only changing the luminance. Okay, darker, lighter, or we can change the saturation, or we can change the tone. So a similar color but with a different tone. But the important thing here is that we have a range of colors that we can see here. But when we are representing images, we are not taking all the colors, only a subset. This is the color space. And to map a number to a point here, we are using the color model. And probably the most used color models are RGB, HSL, and SI-UT1-G2-12 from this is most used for printing because it's those are additive colors, and this is made of subtractive colors, but I don't want to talk very much about the theory. So this is what you need to take in account when representing images with computers.